one together. So in a Rolex watch, the hour hand has half the length of a minute hand. How does the centripetal acceleration of the hour hand compare to the centripetal acceleration of the minute hand? So this is very similar. So it's challenging, given and you see all the numbers. It's sort of like a little bit, okay, this is not trivial. It's kind of a ratio type question. I got to think about how a watch works. But very similar to the last problem. So I'm sort of like thinking through my head, okay, I'm comparing, read through the question, I can compare centripetal acceleration. So I immediately go to, I'm comparing basically v squared over r's. The v's, but there's no really information here about the v. I do have the r, but things I do know about watches are their periods or their frequencies. But knowing periods is a little easier, right? We all hopefully know like that's the piece. So that's the kind of cognitive steps that go through my head. Like I didn't talk out loud, but that's where that's the stuff that's going in my head. Like, okay, I'm going to A. Okay, V's not going to work. Frequency is kind of awkward, but T sounds good. I can maybe determine T. So it's actually I'm going to use the exact same formula as I did in the previous question. And I'm going to write them as a ratio, so I can figure out what this fraction here is here at the end. So I want to know that the A hand over A minute. And I'm going to write this as 2 pi over T of the hand, hour hand, squared times R of the hour hand over 2 pi over T of the minute hand, all to be squared times R minute. And then so the 2 pi squared piece will go away on both sides here. So I'll be left with RH, R of the hour hand, over TH squared, all divided by R of the minute hand over T minute hand squared. That makes sense. Again, stop me if I make a mistake. I'm likely to make a mistake at this point. So AH over AM is, so I'm going to flip these upside down. So it's divided by a fraction, so I turn the bottom fraction upside down and multiply. So R hour over TH squared times T minute squared over R M, right? Yeah. Okay, so I'm down to that part. And now I do my work. So if I make, let's say, the hour hand has half the length of the minute hand, so I'll make the minute hand L, and I'll make this half L. So I'll just make this 0.5, so the L's will cancel. So I'd have 0.5 for the hour hand and just 1 here for the minute hand. Go ahead and chat with your neighbor about what is the period of the hour hand and the period of the minute hand. It's hard, right? Isn't it? It's like, how do watches work? We're all wearing like digital watches. So how long does it take the hour hand to go around? Maybe someday we'll all have Rolexes, but it's a good dream. So you could go in seconds if you want. Here, since I'm going to go ratio, I'm going to just stick to hours. So we have a clock. We have a clock at the back. There's only 12 hours on the clock face. So the small little hand takes full 12 hours, right? Alright, so let's say it starts at 12 o'clock. 1, 2, 3, 4, 5, 6, all the way around to 12. The hour hand takes 12 hours to do one full revolution. The hour hand. No, it's small. The hour hand is a small. Yeah? Are we recording this? The minute hand go takes 1 hour. So that should be 1 over half times 12 squared. So that's 144 times 2, 288. Yeah, the 2 comes from the half up here on the top. All good?